You're back for 3i Atlas. Same visitor, new gear. Last time we wrestled with how a frame can look sunward. Tonight we open the case file and ask what this object is made of, how its surface wakes under sunlight, and which signatures whisper where it was born. Less courtroom drama, more lab bench. Mystery with measurements. Start with a clean premise. Sunlight is not a paintbrush. It's a probe. When it hits a comet's face, it doesn't just brighten the scene. It tunnels heat, wakes volatiles, lifts grains, and leaves fingerprints in timing, color, and texture. If you listen for those fingerprints instead of headlines, a still photo becomes a diary entry. That's our move tonight. Turn photographs into field notes and field notes into a story. Tab 1. Surface versus sunlight. Some nuclei behave like tidy thermoses. They absorb heat slowly, leak slowly, and respond with a gentle curve. Others are a patchwork quilt. Porous spots, crusted slabs, vents that wake like stubborn roommates. If 3i Atlas falls into the quilt category, its brightness won't just rise, it will stutter. Little steps or plateaus as sunlit patches switch on and off. We'll watch for step changes rather than smooth slopes. Steps say layered skin. Slopes say blanket. Either answer moves the case forward. Evidence lives in pace, not just place. If activity peaks a bit after local noon on the nucleus, the subsurface is acting like an insulator. Heat soaks in before gas escapes. If activity leads noon, the upper centimeters are low inertia. Think powder that flashes early. The offset is tiny but testable. Call it a heat lag clock. The hands on that clock can point to crust, pores, or trapped volatiles. We'll read it carefully. Tab 2. Color and texture. Color is not cosmetics, it's physics. A bluer hue near the core can mean fine, fresh grains or gas scattering, adding a cool tint. Redder farther out can mean grains clump, bake, or simply sort by size in the outflow. If the center of the coma is slightly blue and the outskirts trend red, the nucleus is serving espresso shots of fine dust that assemble into lattes of bigger, redder clumps as they travel. If the whole coma trends red uniformly, compact grains rule the day. Neither verdict is romantic, but both are revealing. We'll measure a color gradient triangle, inner, mid, and outer coma, on multiple nights. If the triangle flips orientation as the object warms, the surface is changing who gets launched. That flip is a note from the top few centimeters. Today's crust, not ancient lore. The case file needs both. Tab 3. Polarization. Yes, the word that scares away dinner guests. Light scattered by fluffy aggregates becomes polarized differently than light bounced off compact grains. We'll sample polarization across a small phase angle range. A steep rise points to airy, clumpy dust, grains stuck together like snowflakes. A flat response argues for compact processed stuff, the kind you'd get after a few thermal seasons. If 3i Atlas lands on the fluffy side, it smells like nursery dust from a cold, gentle disk. If not, think survivor. Processed, crusted, maybe baked before ejection. That single curve narrows the birth zip code more than a dozen exclamation points on social media. Tab 4. A quiet favorite, sodium. Some comets leak a faint sodium tail, a thin golden whisper that isn't dust and isn't ions. It follows its own rules. If a sodium feature shows up for 3i Atlas, it flags freshly exposed sodium-bearing minerals, or a release mechanism we don't catch often. It's rare, photogenic, and easy to mislabel. If we find it, we name it before the internet calls it a tractor beam. Tab 5. Spin state. Not just how many hours, but whether the spin axis precesses or wobbles. Uneven venting can torque a nucleus. If the direction of the brightest inner coma drifts night to night without a clean change in period, we're watching nutation, a smaller wobble riding the main spin. Wobble implies vent asymmetry and shape irregularity. Shape irregularity hints at a lumpy interior or off-center mass. That, in turn, leans on bulk density and cohesion. A wobble is a joke with a punchline. The nucleus isn't a neat potato. It's a potato with opinions. Tab 6. Non-gravitational push. Outgassing is a tiny rocket. Over weeks, it nudges the orbit. If 3I Atlas drifts measurably from a gravity-only track, the sign and size of the push reveal whether venting is directional and whether the body is light and fluffy or compact and stubborn. Stronger push with modest brightness can mean asymmetric vents on a low-mass object. Weak push with big shows can mean heavy, compact, or venting that cancels itself. Yes, we are inferring thrust from a speck across the void. Welcome to planetary forensics. Tab 7. Outbursts and fragments. Outbursts are not rude, they're informative. Fast rise and slow fade says cap popped, pressure released. Slow rise and fast fade says surface simmer, turbulence died. If microfragments peel away, we note sizes and lifetimes. If fragments differ in color or polarization from the main coma, the interior is layered. If they match, the recipe is consistent throughout. Either way, fragments are the universe handing you a scoop without a lander. Hold that gallery in one hand. In the other, grab a map labeled Origin Hypotheses. Cold nursery with gentle sticking and low compaction yields fluffy aggregates, high polarization swings, bluer cores, and modest sodium if fresh minerals show. Warm suburb processing yields compact grains, low polarization change, deep heat lag, crusted surfaces, outgassing torques, and more dramatic non-gravitational pushes when vents fire unevenly. We're not deciding alien versus normal. We're pinning a square on a map that says this recipe lived here. Let's walk through 3 fresh tests we promised and make them practical. Test 1. The color gradient triangle. We sample color in 3 rings: inner, mid, outer. Night 1 shows blue, neutral, red. Night 2 shows blue, neutral, red again, but the differences shrink. Night 3 flips to neutral, blue, neutral as gas scattering spikes near the core and fine grains start to dominate longer. Interpretation A. The surface started with pockets of fine material that clumped as they escaped. Later, gas flow increased close to the nucleus, briefly turning the inner coma cooler in color. Interpretation. Illumination geometry shifted and highlighted a jet that throws finer grains, consistent with a patch waking, not a global change. The winning story is the one that also fits polarization and timing. 1 measurement is gossip. 3 in harmony is testimony. Test 2. Polarization mini-scan. We take a narrow sweep and phase angle on 2 consecutive nights. The curve rises sharply the first night, then flattens slightly the second. That pattern says the dominant grains changed texture. Fluffy aggregates first, then partial compaction or a different mix, possibly because different patches took over. If the peak angle shifts, the aggregate's characteristic size changed. A subtle whisper from the way grains stuck together in another system's nursery. That whisper is why we do the scan even when it bores the algorithm. Test 3. Heat lag clock. We track activity relative to local noon. The peak lags by, say, tens of minutes, then grows to a bit more on warmer days. That gradation says the subsurface is storing heat across a growing skin depth. If an outburst interrupts the pattern, we annotate it. A vent exposing fresh volatile can reset the clock locally. The lag curve over a week becomes a terrain map without a photograph. You can circle smooth, stubborn, and chaos zones with a pencil. Now outcomes. Not one right answer, 4 coherent end states. Outcome A. The fluffy world builder, high polarization swing, blue to red gradient outward, gentle stepped brightening, modest non-gravitational drift, occasional soft outbursts. Translation. Fragile aggregates, low density, patches waking like lights in an apartment block at dusk. Origin tilt. Formed far from a star, preserved delicate structure, ejected without much bake. Planet formation relevance. Grains like these are easy to compact in a gentle disk, the starter kit for planetesimals. Outcome B, the crusted survivor flat polarization curve. Uniformly red coma, strong heat lag, measurable thrust. Microfragments that match the coma composition. Translation, processed shell, pressure pockets below, vents acting as valves. Origin tilt, lived closer to warmth or cycled heat before ejection. Planet formation relevance. This is dust after a few seasons. Tougher, more compact. Harder to stick in a cold nursery, but a resilient traveler between stars. Outcome C. The sodium siren, neutral core color, thin off-axis golden whisper, intermittent sodium signature, polarization, ambiguous. Translation. Fresh sodium release from minerals not often exposed, or an unusual transport path for alkalis. Origin tilt, a composition quirk, either a niche layer or a parent system with different rock recipes. Relevance, flags diversity in building blocks beyond what we catalog in our backyard. Outcome D, the wobbly spinner period holds, but highlight direction drifts. Heat lag clock inconsistent. Thrust shows a preferred direction. Translation, precession or nutation from asymmetric vents on an irregular shape. Origin tilt, lumpy nucleus with off-center mass or heterogeneous strength. Relevance, spin state evolution is a free probe of internal structure. Mass distribution without a flyby. Let's add 2 case studies from the fresh file, not repeats of last time's illusions. Case study, the stair-step evening. On a quiet space weather night, the light curve climbs in 3 small steps, 15 minutes apart. Color near the core blips bluer on the second step, then returns. Polarization ticked up between step 1 and 2. We infer 3 patches, a wakes, then B with finer grains, then C more compact. The sequence says the skin is not uniform. It's a mosaic that sunlight reveals tile by tile. This pushes 3i Atlas toward a layered, patchy face rather than a single texture shell. Case study, the uninvited whisper. A faint sodium line appears on one night, off-axis from both the dust fan and any expected ion ray. The feature is subtle, repeats briefly, then vanishes. There's no space weather drama to blame. That points to a transient exposure of sodium-rich material. Either a small cap blew or a crack widened and then sealed with frost. This is why we log outbursts carefully. Chemistry hides in timing. Now, how to observe like a pro without a 10-meter telescope. 3 tracks with real impact. Track 1. Photometry with discipline. Same filter, same aperture, same cadence. Note seeing, sky transparency, and exposure. You're not trying to be fancy, you're trying to be consistent. Consistency turns small telescopes into a global array. Track 2. Color mini sequences. Rotate 2 or 3 broadband filters in a tight loop for 20 minutes, then lock back to the main band. Even if calibration is imperfect, trends survive. Trends feed the gradient triangle. Track 3. Polarization snapshots. If you have a polarizer or a basic polarimetric setup, grab short sequences at a few angles. Even low SN data can hint at curve shape when combined across nights. The case file loves humble data that repeats. Data hygiene is part of professionalism. Timestamp everything. Keep raw and reduced. Write down when you changed a setting. Lies don't usually come from malice. They come from forgetting. The universe forgives curiosity. It does not forgive sloppy notebooks. A few myths to retire while we're here. Myth 1. Redder means older. Sometimes. Often it means larger or more compact grains or more path length. Context decides. Myth 2. Outbursts are mistakes. No, they're wind conditions, the object volunteering a stress test. Myth 3. Non-gravitational drift is negligible, only until it isn't. Over weeks, tiny thrusts become measurable maps of vent asymmetry. Ethics brief, because we all live on the same internet. Credit images and data, share calibration quirks. Don't crop away the sun arrow and then dunk on strangers. Teaching beats dunking. Science is a group project with no bell curve. Zoom the frame back to planet building, because that's why any of this matters. In a young disk, grains stick by electrostatic forces, then by ice, then by gravity. Fluffy aggregates are the freeway on-ramp. Compact grains are later traffic. Knowing which one dominates in 3i Atlas tells us whether other systems export builders, survivors, or both. If interstellar visitors keep arriving with similar dust physics, we learn the median recipe. If they scatter across the menu, we learn the variance. Mean and variance beat vibes. You might ask, what could actually surprise us? 3 candidates. 1. A persistent sodium tail that survives changing geometry and refuses to align with either dust or ion narratives. That would hint at a production channel we don't model well. 2. A polarization curve that looks like nothing in our comet catalog, either too steep or oddly flat, signaling grain physics we haven't met. 3. A heat lag reversal, peaks consistently leading noon by a large margin, implying a skin that vents faster than it warms, or a structure with hidden pathways for gas. Any of those would tighten the foreignness stamp beyond chemistry. If a standby interceptor ever meets the next visitor, our case file turns into a flight plan. Sniff gas while sampling dust size and charge in the inner coma. Log the magnetic sector in situ, time a jet spike near closest approach, and grab a polarimetric burst while passing the vent plane. 2 alignments out of 3, and we calibrate remote sensing for the next decade. Pictures become meters. Arguments become plots. All right, where does tonight land us? We have a plan to read the surface, a way to time the heat, tools to grade texture, and a nose for sodium. We've set outcomes that mean something even if they're not flashy. None of this needs a miracle. It needs patience and notes. Mailbag lightning round. Could organics dominate the show? They can color it and scent it, but they rarely run the theater alone. If organics track with CO-like signals instead of water, we'll log the hint and stiffen the cold origin case. Do 2 observers ever disagree the same night? Yes. Different exposures, apertures, and geometry emphasize different layers. That's not contradiction. That's tomography. Why no big prediction window this time? Because diagnostics first, theatrics later. We did the window once. Tonight we build the baseline the window stands on. Here's your observer's cheat sheet for the week. If you see step-like brightening, log start, stop, and size. Note seeing and filter. If your inner coma color flips cooler for a spell, write the time. Confirm it isn't calibration drift, by repeating the loop. If polarization spikes, note phase angle with care. 2 points beat 1, 3 outline the curve. If a thin golden streak appears, don't panic. Annotate orientation and duration and mark it candidate sodium. If your period refuses to sit still, try fitting a slow drift term. Wobble often hides there. If your orbit fit demands a tiny push, document it and resist the superhero headline. Non-grav term updated is the adult move. We're nearly at engine cutoff. The headline for tonight is not a single word. It's a stack. Surface, color, texture, heat, spin, push oddities. Each layer narrows 3i atlas from a comet from elsewhere to this kind of comet from this kind of elsewhere. If the stranger resists our boxes, excellent. That's how new boxes are born. Closing arc, clean and honest. The universe is not obliged to be simple, only to be consistent. 3i Atlas does not owe us spectacle. It owes us evidence. We repay with patience, labels, and the occasional joke to keep the lights on. Next time we stay with 3i Atlas, but we change gears again. Not the sunward optics, not tonight's diagnostics. We widen the hunt to the strangest rules across interstellar visitors, ghostly ion rivers, orphan tales, offbeat spins, and what they reveal about new worlds under construction. If you want the mystery with the math, subscribe to Night Sky Narratives and come back for the hunt. The night sky keeps secrets. Bring coffee. Space stays up late.